Good afternoon. You're looking at a live view of Launch Complex 39A at NASA's Kennedy Space Center in Florida, where SpaceX is counting down to liftoff of a Falcon Heavy rocket at 5:56 p.m. Eastern Time. That is 22:56 UTC for those of you watching around the world, about an hour and 10 minutes from now. This mission will mark the fifth flight of a SpaceX Falcon Heavy rocket, dating back to the famous inaugural test flight that carried one of Elon Musk's Tesla Roadsters into heliocentric orbit. That was back on February of 2018. 3 additional Falcon Heavy rockets have launched since then. Today is Flight 5 for SpaceX's Falcon Heavy, one of the most powerful rockets in the world and the most powerful commercial rocket anywhere in the world that is currently operational. This mission is for the U.S. Space Force. It's named USSF-67. And on board the Falcon Heavy out at Pad 39A are 2 U.S. Space Force satellites. One is a military communications spacecraft. The other hosts a number of tech demo and prototype experiments that will be infused in the future into operational military programs. The view you're looking at live right now from Launch Complex 39A is provided to us by SpaceX. It's one of SpaceX's cameras. We're not controlling this particular view. It's an up-close shot of the Falcon Heavy, the strong-backed vertical up next to the vehicle. The Falcon Heavy stands 229 feet tall. It's about 70 meters in height. And with the 3 Falcon booster cores strapped together, that rocket has a width of about 40 feet or 12.2 meters. My name is Stephen Clark. I'm the editor of Spaceflight Now, and I'll be providing commentary throughout the SpaceX countdown this afternoon as the company targets liftoff at 5:56 p.m. Eastern Time, 22:56 UTC, just about 10 minutes or so after sunset on Florida's Space Coast. And with clear skies, this should be a spectacular launch visible up and down the Florida Peninsula, with the Falcon Heavy climbing into sunlight just a few moments after liftoff, and we expect to see the engine plume from the 27 engines of the Falcon Heavy illuminated against a darker sky as the Falcon Heavy makes its way into space, heading due east from Kennedy Space Center. If you haven't done so yet, we ask you to please hit the like button. That's the thumbs up button here on our YouTube stream. That helps us gain a larger audience for our coverage. We want to bring this spectacular twilight launch to as many people as possible. And to help us do that, please hit the like button on our YouTube stream. SpaceX's countdown now is passing T-minus 1 hour, 7 minutes. There's a 37-minute launch window available tonight that opens at 5:56 p.m. and runs until 6:33 p.m. Eastern Time. The launch had been scheduled for yesterday or Saturday around the same time, but SpaceX yesterday afternoon announced that the launch will be delayed 24 hours. That's because preparations for the mission ran a little bit behind schedule late in the week and into Saturday. The rocket was not lifted vertical on the pad until shortly after noon, around 1 p.m. local time yesterday, just about 5 hours before the opening of the launch window. And SpaceX typically needs longer than that, often 8+ hours before the launch window is when the Falcon rocket needs to be vertical for SpaceX technicians to perform final checkouts and ready the rocket for the countdown, which will get underway in earnest coming up in the next few minutes with the loading of propellants onto the Falcon Heavy rocket. The loading of kerosene and liquid oxygen is expected to begin at T-minus 50 minutes, beginning with kerosene, and at T-minus 45 minutes with the cryogenic oxidizer. T-minus 1 hour, 3 minutes, 21 seconds, and counting. We're about 10 minutes away from the expected time we should hear from SpaceX Launch Control that the launch readiness poll is complete. Members of the Falcon Heavy launch team are working out of firing room 4 of the Launch Control Center, which is just outside the vehicle assembly building at Kennedy Space Center, about 3 miles from Launch Complex 39A. And that's where engineers and managers are gathered from SpaceX as well as the customer, the U.S. Space Force, to monitor this afternoon's countdown operation. We want to thank Space Pony for gifting memberships to our viewers. We really appreciate that support. You can support our coverage by contributing in the Super Chat here on YouTube. You can also become a member. Click the Join button on our YouTube channel. We have different membership tiers available for you to choose from depending on which level you choose. You can get access to exclusive members-only video features from our launch coverage on Florida Space Coast and around the world. The official launch weather forecast this evening calls for a better than 90% chance of favorable conditions locally at Kennedy Space Center for the launch. There is some uncertainty about the sea conditions downrange. One of SpaceX's recovery ships is stationed about 1,000 miles east of Kennedy Space Center out in the Atlantic Ocean to retrieve the 2 payload fairing halves from the top of the Falcon Heavy. Once they jettison off the rocket, they'll parachute into the Atlantic Ocean. And there are some rough seas out in the Atlantic this evening. But we're not sure and haven't heard any indication from SpaceX that that will be a constraint for launch tonight. The 2 side boosters will be returning to Cape Canaveral Space Force Station 8 minutes after launch. So those boosters will be coming back to the launch site, landing on about 9 miles south of the launch pad itself. So no drone ship to worry about tonight out in the ocean, so no issue there. And the weather, as I mentioned up front at the start of our broadcast, the weather conditions at Kennedy Space Center are near ideal for launch this evening. T-minus 58 minutes, 30 seconds. Now 5.5 minutes away from the expected time of the conclusion of the launch readiness poll that will give the go or no-go to proceed into propellant loading on the Falcon Heavy rocket this evening for its twilight launch, scheduled for 5:56 p.m. Eastern Time, 22:56 UTC. T-minus 55 minutes, 13 seconds and counting. The Falcon Heavy rocket out on pad 39A will be powered off of the planet by 27 Merlin 1D engines. You see those engines here in this photo from SpaceX taken a little more than a week ago during final preparations for the launch. This is a picture of the Falcon Heavy's 3 Falcon booster cores bolted together inside the hangar at pad 39A. These 27 kerosene-fueled engines will generate about 5.1 million pounds of thrust at full throttle at liftoff. The center core stage of the Falcon Heavy will actually throttle down shortly after launch to a partial thrust mode to conserve propellant, because that engine, or that booster, that center booster, needs to burn about 4 minutes on this evening's flight. Typically, the Falcon 9 boosters burn about 2.5 minutes on the way up to space. So that center core will throttle down to save some fuel to burn longer during tonight's flight, while the 2 side boosters will power at full throttle. Those 2 side boosters will burn about 2 minutes and 24 seconds before shutting down their engines and separating. They'll peel away from the core stage, and then actually they'll reignite a subset of their engines, 3 engines, for boost back burns, each of them, to begin powering themselves back toward Cape Canaveral for landing. Those 2 side boosters will land at landing zone 1 and 2, about 9 miles or 15 kilometers south of pad 39A, 8 minutes after liftoff. The center core stage, after it separates from the Falcon Heavy upper stage, around 4 minutes into the flight, will actually fall back into the atmosphere and will not be recovered. SpaceX will not make an attempt to recover the center core stage on tonight's flight. It'll dedicate and use all of its propellant to delivering the 2 U.S. Space Force payloads to their high altitude orbit. The upper stage will actually do the final maneuvers to place these 2 payloads into geosynchronous orbit.
Polling is complete.
It'll take about 6 hours for the upper stage to complete what we expect to be 3 different burns to place the payloads into geosynchronous orbit more than 22,000 miles, about 36,000 kilometers over the equator. We just heard a confirmation from SpaceX Launch Control that the team is go for propellant loading and launch, a good sign as we're now 52 minutes, 30 seconds away from liftoff. Propellant loading will begin at 50 minutes before launch.
Countdown, a reminder on abort instructions. For non-urgent no-go conditions, brief CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold, hold, hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed to the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands off and relying on automated abort criteria for the remainder of the count. Here in firing room 4, in the event of a fire alarm, key operators noted below in the procedure will remain at their post while the alarm is evaluated. In the event that personal safety is threatened, we will evacuate to the south-facing emergency exit, which leads directly outside.
That was the voice from SpaceX Launch Control briefing the launch team on their final procedures they'll need to follow during the terminal countdown in the event of any abort or emergency. But everything looking good now. The countdown has passed T-minus 50 minutes.
Launch auto sequence has started.
And we just heard the call that launch auto sequence has started. So kerosene fuel, called Rocket Propellant 1, is now flowing into the 3 Falcon Heavy booster cores at pad 39A. This is the first step of propellant loading this evening. This will be followed at T-minus 45 minutes with the start of liquid oxygen loading on the 3 Falcon Heavy first stage booster cores. And then at T-minus 35 minutes, loading of propellant on the upper stage will get underway. SpaceX's countdown now approaching T-minus 45 minutes. And at that point, liquid oxygen should begin flowing onto the 3 Falcon Heavy boosters at pad 39A. Everything looking good for launch at 5:56 p.m. Eastern Time, 22:56 UTC. SpaceX's countdown is at T-minus 41 minutes, 37 seconds. For those of you who have watched our coverage of Falcon 9 launches, the countdown is a bit different for the Falcon Heavy. For Falcon 9s, which are launched with a single first stage booster, propellant loading doesn't actually start until T-minus 35 minutes. As we saw today for Falcon Heavy, because there's so much more propellant to be loaded with 3 Falcon booster cores together, the propellant loading begins for the Falcon Heavy at T-minus 50 minutes. So that started 9 minutes ago. Liquid oxygen loading got underway at T-minus 45 minutes. And then coming up at T-minus 35 minutes will be the start of loading of kerosene fuel onto the second stage of the Falcon Heavy rocket out at pad 39A. And then at T-minus 18 minutes, 30 seconds, liquid oxygen will begin loading onto the second stage. So it's a staggered propellant loading process for the Falcon Heavy countdown this evening. 40 minutes, 30 seconds to go in this evening's countdown. Here are some images of the Falcon Heavy rocket on pad 39A taken over the last couple of days. The Falcon Heavy completed a test firing or static fire test of its 27 main engines last Tuesday on pad 39A. SpaceX rolled the Falcon Heavy back to the hangar for integration with its payload compartment. That payload fairing was moved to encapsulate the two U.S. Space Force payloads in an off-site payload processing facility, and then that payload fairing was moved to the hangar at pad 39A for integration with the Falcon Heavy rocket last week. The Falcon Heavy, with its payload fairing, rolled back to pad 39A on Friday, or Saturday morning actually, and was lifted vertical shortly after noon yesterday. So these images from SpaceX on the left show the payload fairing with its U.S. Space Force logo, as well as the mission patch for the USSF-67 mission. That logo is on the payload fairing, and I'll draw your attention to the gray stripe, the gray paint at the bottom of the second stage, at the very bottom of the image on the left here. That's some paint that is used as thermal insulation on the kerosene tank of the second stage. We've mentioned that this mission will take about 6 hours to deliver the payloads to geosynchronous orbit, more than 22,000 miles over the equator. And SpaceX has added this band of gray paint on the outside of the kerosene fuel tank on the second stage to help prevent that fuel from freezing as the rocket coasts through the very cold environment of space for 6 hours until that last critical burn of the second stage engine to set the stage for separation of the two payloads on tonight's flight. So with the 5:56 p.m. launch, we don't expect to get confirmation of the final payload deployment and final mission success until sometime after midnight Eastern time. That's about 5 a.m. UTC. The images on the right, on the upper right, show a view from one of our Spaceflight Now cameras at the press set showing the rollout of the Falcon Heavy yesterday morning. And on the lower right, the fully integrated Falcon Heavy on the pad yesterday. That image comes from SpaceX. The countdown is just past 38 minutes until liftoff, so we're now about 3 minutes away from the next major milestone, which will be the start of kerosene fuel loading on the second stage. And here's a look at the countdown timeline that I've been talking about. This chart shows some of the major milestones. We've already passed a couple of these milestones at T-minus 50 minutes with the start of propellant loading at T-minus 45 minutes. Liquid oxygen began pumping onto the 3 Falcon Heavy first stage boosters. Looking ahead, at T-minus 35 minutes will be the kerosene loading on stage 2. At T-minus 18 minutes, 30 seconds, the super cold cryogenic liquid oxygen for the second stage will begin flowing into the vehicle. At T-minus 7 minutes, the 27 Merlin engines on the 3 first stage boosters will begin their engine chill down process. This is a thermal conditioning effort to prevent or protect these engines from the thermal shock of liquid oxygen flowing into those engines at engine ignition. The liquid oxygen is chilled down below 200 degrees, minus 200 degrees Fahrenheit, close to oxygen's freezing temperature. This makes this oxygen densified, and it allows SpaceX to cram more molecules of liquid oxygen into the propellant tank. That adds to the performance of the Falcon Heavy rocket during the launch. It also ensures that the rocket has enough reserve propellant to return those 2 side boosters back to Earth for recovery and reuse. At 4.5 minutes before launch, the strongback out at pad 39A, that's the structure just to the right of the Falcon Heavy, will retract to a very slight angle of about 1.5 degrees from the rocket. At T-minus 2 minutes, the rocket should be fully loaded with all propellants. And at that point, the fill and drain valves will be closed. At T-minus 60 seconds, the Falcon Heavy onboard computer will take command of the countdown. And at T-minus 45 seconds, the SpaceX launch director will give their final go for launch. At 20 seconds, the propellant tanks will be pressurized. They'll be brought up to flight pressure. And then engine ignition, that sequence begins at T-minus 6 seconds. If the engines all look healthy, if all 27 engines throttle up to full power, hold down clamps will release at T0 to allow the Falcon Heavy to begin its climb into space.
Stage 2 RP1 load is starting.
And we just heard the call from SpaceX Launch Control that the kerosene loading on stage 2 that we talked about starting at T-minus 35 minutes has indeed begun. So the next phase of the countdown is now underway with loading of propellants onto the second stage of the Falcon Heavy. This is the part of the rocket that will be used for 3 burns tonight to place the U.S. Space Force's new military communications satellite, as well as the LDPE-3A prototype satellite into geosynchronous orbit. SpaceX's countdown just passed T-minus 30 minutes. Everything looks to be on schedule for liftoff at 5:56 p.m. Eastern Time, 22:56 UTC, to begin the USSF-67 mission for the United States Space Force. We're looking live at Launch Complex 39A at NASA's Kennedy Space Center in Florida. You're seeing some of the vapors venting from the strongback, as well as some condensation and frost building up on the boosters, the two side boosters out at pad 39A. This comes from the loading of the cryogenic liquid oxygen several hundred degrees below zero as it's pumped into the boosters on the Falcon Heavy rocket. Ice and frost can build up on the outer skin of those rocket elements, and you can see some of the scorch and soot markings from the previous flights of those two boosters. That gray color is now being covered up with the white frost, so you can see the loading of propellants continues out at pad 39A. 28 minutes, 45 seconds to go. This will mark the 5th flight of a SpaceX Falcon Heavy rocket, and is actually the first of as many as 5 Falcon Heavy missions SpaceX plans to launch this year. Later in the year, in the March timeframe, currently, as current schedules show, SpaceX plans to launch its next Falcon Heavy with a Viasat broadband communications satellite. That'll be followed in April with the launch of another Space Force mission on a Falcon Heavy. And then in the late spring or summer timeframe, SpaceX plans to launch the Jupiter 3 broadband commercial communications satellite for Hughes Network Systems and EchoStar on a Falcon Heavy. And then in October, another Falcon Heavy is set to launch NASA's Psyche asteroid mission. All those flights will depart from pad 39A at NASA's Kennedy Space Center. SpaceX's countdown now is at T-minus 25.5 minutes until liftoff of the Falcon Heavy rocket from Launch Complex 39A. We talked about the upcoming Falcon Heavy missions. Again, this is the first of 5 Falcon Heavy launches on SpaceX's schedule for 2023. Let's take a look back at the 4 previous Falcon Heavy launches. The first Falcon Heavy rocket launched back on February the 6th of 2018. That was the inaugural test flight of the Falcon Heavy. They carried a Tesla Roadster as the dummy payload, essentially, into a heliocentric orbit. So it launched that Tesla Roadster automobile away from the Earth on an escape trajectory into solar orbit. That was a successful debut for the Falcon Heavy. And then the Falcon Heavy entered operational service a year and a few months later on April the 11th of 2019. The Falcon Heavy launched with Arabsat 6A. That was a Saudi Arabian commercial communications satellite. 2 months later, June 25th, 2019, the third Falcon Heavy launched. That was the first night launch of a Falcon Heavy with the Space Test Program 2 mission for the U.S. military that carried 24 small satellites into orbit for NASA and the Defense Department. And then most recently, after a gap of more than 3 years, the USSF-67 mission launched on a Falcon Heavy on November the 1st of last year from Pad 39A that carried 2 military satellites into geosynchronous orbit, and it was actually the mission that used the 2 side boosters that are set to fly again on this evening's mission. So the 2 side boosters on the USSF-67 mission came back to Cape Canaveral for landing. They were refurbished, and now they're being reused on tonight's flight for the Space Force. And if all goes according to plan, they'll be reused again on the next Space Force launch on a Falcon Heavy in the April timeframe. You can see it's now golden hour at Kennedy Space Center in Florida, 23 minutes, 20 seconds until liftoff. Approaching sunset in the next 10 to 15 minutes on Florida's Space Coast. Liftoff is scheduled around 10 minutes after sunset local time at Kennedy Space Center. In the next few moments, we expect to see the so-called big vent from the strongback out at Pad 39A. And we're now seeing that big vent underway. That coincides with the end of kerosene loading, kerosene fueling on the second stage. So at this time, the kerosene tank on the second stage should be fully loaded. And now preparations are underway to load liquid oxygen onto stage 2.
Stage 2 RP1 load is complete.
We did just hear that call from SpaceX Launch Control that RP1, or Rocket Propellant 1, loading on the second stage is complete. That's the kerosene fuel that will feed the Merlin vacuum engine on the second stage for tonight's mission. Rocket Propellant 1 is a highly refined rocket-grade kerosene.
Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has
7,
started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello, everyone. You are looking at a live view of Falcon Heavy on historic Launch Complex 39A at Kennedy Space Center, awaiting liftoff at 5:56 p.m. Eastern Time. Welcome to our live webcast of the USSF-67 mission from SpaceX headquarters in Hawthorne, California. My name is Jesse Anderson. I'm a production engineering manager here at SpaceX, and I am so excited to be here with you today, bringing you coverage of our first Falcon Heavy mission this year and 5th of all time. Today's mission is a national security space launch mission for the United States Space Force, our second Falcon Heavy mission for the Space Force in about 2 months. Now, just like USSF-44 last November, USSF-67 will launch into a geosynchronous Earth orbit from Launch Complex 39A in Florida. Now, additionally, at the request of our customer, we will again not be showing views of the payload. So we will be ending the webcast just after Falcon Heavy's side boosters make their way back to land on Landing Zone 1 and Landing Zone 2 around the T+8 minute mark into flight. Now, in addition to covering today's launch, we're excited to be joining you this weekend as Monday is Martin Luther King Jr. Day. Every third Monday of January, we celebrate the life and legacy of Dr. Martin Luther King Jr., who fought for racial justice and equality for all. Here at SpaceX, we believe that in order to achieve our goals of making humanity multiplanetary, it is essential to create a team with diverse backgrounds and cultures. As we remember Dr. King's legacy this weekend, I hope that we can keep working towards furthering equality every day of the year. Now back to the mission at hand. At T-minus 13 minutes and counting, all systems are currently go for an on-time liftoff. The vehicle is nearly fully loaded with propellants and will complete at T-minus 2 minutes. The range is also green and ready to support. If for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. Now, at just under T-minus 13 minutes, let's take a closer look at the Falcon Heavy vehicle that you see there on your screen. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which means it can carry much larger payloads, not only to Earth orbit, but to the Moon and Mars as well. Now, like Falcon 9, Falcon Heavy is a 2-stage launch vehicle. Now, the big difference is that the Falcon Heavy first stage is comprised of 3 cores, whereas Falcon 9 only has 1. Falcon Heavy has 28 engines in total. Each of these cores has 9 M1D engines, making for a total of 27 engines across all 3 boosters, which you can see there on your screen. The 28th engine is a Merlin vacuum engine on the 2nd stage and will power the payload to its final targeted orbit. Now, altogether, the Merlin 1D engines at the base of Falcon Heavy produce 5 million pounds of thrust. That's equal to 18 747s at takeoff. Now, in fact, the engines produce so much power that we don't run them at full thrust all at once until after liftoff. About 2.5 minutes into flight, the 2 side boosters will separate from the center core and come back down to Earth for simultaneous landings at Landing Zone 1 and Landing Zone 2, which you can see there on your screen. If successfully recovered, these side boosters will be refurbished and used in a future national security space launch. Now, upon side booster separation, the center core will keep firing for about 90 seconds before shutting down its engines and then perform a standard stage separation from the 2nd stage. We will not be attempting to land our center core today as the mission requires more performance. Now, this means that in order to get our payload to where it needs to go for today's mission, the center core will burn the fuel that we would typically use for recovery. And for those of you looking closely, that is why you don't see any landing legs or grid fins on the center core. Now moving towards the top of the vehicle, once the 1st and 2nd stage separate, the 2nd stage will propel our payload to its intended orbit. At our customer's request, we will not be showing views of stage 2, so immediately after the Merlin vacuum engine on the 2nd stage fires up, we'll be directing all of our attention to the landing of our side boosters. Now, above the 2nd stage is where our payload is safely enclosed inside of the fairing. That's at the very top of the rocket there on your screen. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. Now, once we reach the vacuum of space, we will jettison the fairing as the 2nd stage continues on its journey to orbit, and we will be attempting to recover the fairing halves today with our recovery vessel, Bob. Now, as I mentioned earlier, today's launch, USSF-67, is a national security space launch mission for the United States Space Force. Now let's learn a bit more from our customer about today's mission.
We depend on space every day to support our way of life, our supply chain, financial systems, weather tracking, and power grids, as well as air, land, and maritime infrastructure. Our U.S. military is the strongest and best equipped force in the world. In the heavily contested space domain, Space Systems Command leads a team of roughly 15,000 guardians, airmen, civilians, and contractors. Headquartered in El Segundo, California, our unbeatable team operates from multiple locations across the U.S. and includes 2 space launch deltas, SLD-45 at Patrick Space Force Base and SLD-30 at Vandenberg Space Force Base. Through unity of effort across the space acquisition enterprise, Space Systems Command delivers to warfighters integrated and resilient space capabilities through 5 program executive offices. Assured access to space, procures launch services and delivers on-orbit capabilities faster and more frequently than ever before, while sustaining ranges for the United States Space Force and commercial partners. Battle Management Command, Control, and Communication delivers tactical and operational command and control capabilities to warfighters, facilitating timely and quality battle space decisions for the joint all-domain fight. Space domain awareness and combat power maximizes the full characterization of space using a wide range of multi-domain assets by rapidly detecting potential and real threats to our nation and allies, which enables decisive action in the space domain. Communications and positioning, navigation, and timing ensures the delivery of resilient capabilities across the acquisition lifecycle, from prototypes to systems on the production line to systems our warfighters have been operating for years. Space Sensing delivers space-based battle space awareness through missile warning, tracking, environmental monitoring, and tactical intelligence, surveillance, and reconnaissance. Our adversaries fully intend to disrupt, degrade, and destroy the U.S. and our allies' ability to access and operate in space. Not on our watch. Space Systems Command is focused on creating and sustaining resilient lethality in space through systems integration, unity of effort, and digital engineering ecosystems. At Space Systems Command, space starts here.
At T-minus 6 minutes and 45 seconds, the SpaceX team continues to count down for launch of our 4th operational Falcon Heavy flight, and all systems are go. Following a successful static fire this past Tuesday, Falcon Heavy rolled out to the pad with the payload at 5:45 a.m. and went vertical about 4.5 hours later. Now, before we began the webcast, the SpaceX launch director...
Booster RP1 load is complete.
The SpaceX launch director pulled the members of the launch team and got a go for propellant loading and launch. And we're currently loading propellant on all 3 first stage boosters as well as the second stage. Now you may be able to hear the live rocket sounds from our launch pad. The pops and hissing sounds that you hear are from propellant loading as well as the launch mount and strong back that the propellant is going through. Falcon Heavy uses 2 propellants, a refined form of kerosene called RP1, or Rocket Propellant 1, as a fuel, and LOX, or liquid oxygen, as an oxidizer. Now, an oxidizer is a type of chemical that a fuel requires in order to burn. The liquid oxygen is chilled below its boiling point so that it has a much greater amount of mass per volume. So basically, we can load more of it into the vehicle. Our fuel is RP1, essentially a purified kerosene. It is safe, easily available, and has a lot of history. And in fact, the Saturn V first stage flown from this very pad on the moon missions also used liquid oxygen and kerosene. And in addition to these two propellants, we also use the chemical TTEB, or triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go, and it's the TTEB that sets the match to the propellant mix. Now, next up, the trusted structure next to the vehicle.
Tanks are pressing for a strong back retract.
And there's that call out just in time. The structure next to the vehicle is called the strong back, or the TE. And in preparation for retraction, the clamp arms will begin to open. There's clamp arms just there that you can see on your screen below the fairing. Those will begin to open up, and once they are fully open...
Back retract in progress.
Once they're fully open, then the TE, or the transporter erector, can begin to retract away from the vehicle, and we did hear that call out that the TE retraction process has begun. Now, as I mentioned earlier, today's launch marks our second Falcon Heavy flight in just 11 weeks. And for those of you following along, a lot will happen in the first 4 minutes of flight. And there you can see on your screen that the clamp arms have begun to open. Once those are fully open, the TE can begin to retract away from the vehicle. Now again, a lot will happen in the first 4 minutes of flight. First, we will light the two side boosters, followed by
booster lock float is complete.
Followed by the center core. And about 40 seconds after liftoff, we will decrease power on the two side boosters to prepare for max Q, after which Falcon Heavy will throttle back up to full power on the side boosters. Now, 2 minutes into flight, we will...
booster lock float is complete.
2 minutes into flight, we will again reduce thrust on the two side boosters, this time to decrease forces on the rocket structure, as the vehicle is now much lighter, but thrust is constant. Now, 2.5 minutes into flight, we will fully turn off the side boosters with booster engine cutoff, or what we call BECO. The pneumatic separation
Center
system.
core lock float complete.
Getting good calls. I'm going to pause for each one of those. The pneumatic separation system on the center core then unlocks the two side boosters and pushes them away. Now, once we are clear of the side boosters, the center core throttles up to full power until the center core shuts down with main engine cutoff, or what we call MECO, and then separates from the second stage around the 4 minute mark. And as a reminder, we will not be attempting to recover the center core today, as the mission requires more performance. Now, for those of you looking closely, this is why you don't see any landing legs or grid fins on the center core. And from this point on, very similar to a Falcon 9 mission, the side boosters will be making their way back down to Earth for recovery. The fairing will separate, and the second stage will take the USSF-67 payload out into space. Now, as a reminder, at the request of our customer, we will not be showing views of the payload, so we will be ending the webcast just after our side boosters.
Stage 2 lock float complete.
Just after our side boosters make their way back down to land on landing zone 1 and landing zone 2, a little after the T+8 minute mark into flight. And as we've mentioned before, launch is hard, and Falcon Heavy is no exception. We are essentially counting down 3 rockets simultaneously, so our team is going to be conservative in case anything pops up in the last couple minutes of the countdown. Now, if for some reason we don't launch today, we do have a backup opportunity tomorrow at the same time. And we did also hear those callouts that propellant loading is now complete on Falcon Heavy.
Gas closeouts.
So we are now going to vent out the liquid oxygen line on the transporter erector. Next up will be Falcon Heavy in startup, and that will be at the T-1 minute mark. That's where the internal flight computers take over the launch countdown.
Falcon Heavy is in startup.
And great news, Falcon Heavy now in startup. We're now just waiting for the final call from the launch director.
This is the mission director. Go for launch.
And excellent news, all systems are go for launch of Falcon Heavy with USSF-67.
T-minus 30 seconds. ...15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine full power. And liftoff of USSF-67. Go Falcon Heavy. Go Space Force. Booster chamber pressures are nominal.
T plus 40 seconds into flight under the power of 5 million pounds of thrust.
Power and telemetry nominal.
Falcon Heavy is headed to space. Now we did throttle down the engines around the T plus 40 second
Vehicle
mark
supersonic.
in preparation for max Q.
Max Q.
And great call out there that we have passed through max Q. That's the largest mechanical stress on the vehicle on ascent. And incredible, incredible views there on your screen. Falcon Heavy in flight. Now next events coming up will be booster engine cutoff, or BECO, followed by separation of the side boosters and followed by their side booster boost back burns. And then will be center core main engine cutoff, or what we call MECO. Again, those events coming up here just under a minute away. That will be BECO. That's where the side boosters engines will shut down. The center core will push those side boosters away from the vehicle. Then those two side boosters can begin to make their way back down to Earth with their boost back burns. And on your right-hand screen, you could see the views from each of those side boosters. Really incredible views here. Again, we will have BECO, side booster, boost back burn, followed by main engine cutoff of the center core here in just a few seconds.
Side booster separation. Side core booster startup.
Incredible views. We just had BECO and separation of the side boosters, and you can see on your left-hand screen that the side boosters have lit back up. They are now in their boost back burn, making their way back down to Earth. Now, those side boosters are returning to Florida under the power of 3 engines. That's 3 of the 9 M1D engines. So next up will be the conclusion. Next up will be the conclusion of those side booster boost back burns, followed by MECO on the center core, as well as stage separation of the center core and the second stage, and then SES-1 or second stage engine start 1. Now, as I mentioned previously, per the request of our customer, we won't be showing second stage views after SES-1. And additionally, our center core or stage 1 is expendable today, so we will not be attempting to recover that vehicle, but we should have some great views like we are seeing right now.
Core boost back shut down.
We should have some great views of those side boosters touching down for landing.
MECO. Stage separation confirmed. And next startup.
And excellent views. We had the
Stage 1 FTSSA has safed.
We did have the shutdown of the boost back burn. We did have the shutdown of the boost back burns on the side boosters, as well as MECO on that center core and stage separation. We are waiting for confirmation of a call out of the fairing separation.
All vehicles are following nominal trajectories.
So currently stage 2 is still making its way to its targeted drop-off orbit, while the side boosters are making their way back down to land. Again, these side boosters have another burn coming up. That will be the entry burn. That will be 3 of 9 M1D engines reigniting. That helps to slow the boosters down in preparation or as they re-enter the Earth's atmosphere. We got some views here from those side boosters there on your screen. Now, at the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land, to our side-by-side landing pads. If we have successful landings today, we'll mark the 163rd and 164th landing of an orbital-class rocket. As I mentioned earlier, the center core will be expendable, and we are not attempting to recover it today.
Side core entry burn startup.
And there you can see on your screen, the entry burns for these side boosters have begun. They're just about 12 seconds long.
PY FTS has saved and NY FTS has saved.
And the entry burns for both side boosters have now concluded. Now next up will be the final burn for each of these side boosters. That is the landing burn. It is just a single engine burn, the center E9 engine. Each one of these M1D engines have about 190,000 pounds of thrust. So that is enough to slow the vehicle down just in time for landing. And you could see the coast of Florida in the background.
Side boosters are transonic.
Now that landing burn coming up here in just about 20 seconds or so. Landing burn will last about 20 seconds long. Again, we are scheduled to land on landing zone 1 and landing zone 2.
Landing burn.
And there are those landing burns have begun on the side boosters, so let's watch as they touch down.
Stage 2 is on thermal guidance. Stage 2 FTS is saved. Booster landing leg deployed.
And what an incredible sight to see as we watch the side boosters touch down for landing. That confirms successful landing of both Falcon Heavy side boosters on landing zone 1 and landing zone 2. Now with these two side boosters, this marks the 163rd and 164th overall successful landing of an orbital class rocket. It's also the 25th landing on landing zone 1 and the 6th landing on landing zone 2. And with successful confirmation of our side boosters landing, that will bring today's webcast to a close.
Insertion.
Now, we'd like to thank the United States Space Force for entrusting us with today's mission. Thank you to the Range and the Federal Aviation Administration for licensing today's launch. And we'd like to thank all of you, our viewers, for tuning in. Now, if you're interested, head over to our website and social media platforms for updates on our next missions and milestones. We hope that you all enjoy the rest of your weekend, and we'll see you again soon.
Mr. Clean Magic Eraser powers through tough messes, so it makes it look like I spent hours cleaning. And you know I didn't.
It makes my running shoe look like new. It's amazing.
It's so good. Makes it look like I have magical powers.
Magic Eraser and sheets make cleaning look easy.
orbital.
RCP chamber pressure looks good.
Doubling up. Roger, roll, Atlantic. Water towers can fly! Yes!
Tango Delta nominal.
Fighting outside SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.
All right, folks. Did the bar move? Yeah, the audio bar moved. You know the drill. It's time for another Intrepid Museum Astro Live. John Galloway here, your host for today. Very special, sort of hot start to the show. No pre-show. We're going to hop right in with the special guests. But you know the drill. Give me some 5x5s in chat. Let me know that you can hear and see what's going on. You're already spamming 5x5s in the chat, apparently. You've seen streams here before. We're going to have some very special guests today. Again, Astro Live, the show that we do with Intrepid Museum up in New York City, an actual museum that's an aircraft carrier that also has a space shuttle and a bunch of cool stuff on board. We have been doing these, you used to call them Virtual Astronomy Live, now we call them Astro Lives, and we do them once a month. It's the third Sunday after the Thursday after the third Sunday, something like that. Just check your calendars and subscribe on YouTube and Twitter and stuff so you know when they are. But that is our plan for the day. We're going to be talking with folks from NASA JPL, the Jet Propulsion Laboratory, about the SWAT mission. I'll let them decode that acronym for you. I guess I could just read on the screen. I put it on the screen, so if I ever needed to explain what SWAT stood for, I could read. It's down at the bottom of the screen. We're going to have live Q&A hopping in with the folks from JPL right here. But really quickly, folks, remember, these things don't just happen. The Intrepid Museum shows are actually made possible through a NASA cooperative agreement awarded to the New York Space Grant Consortium. I'm just going to show that on the screen there so y'all know what's going on. And let's bring our special guests over here so we can get on with the main show. Please welcome our friends from NASA JPL and Summer Ash. How's everybody doing today?
Good, Das. How are you?
We have video and audio from everybody. I see a bunch of videos. I heard some audio. Summer Ash, of course, is going to be our moderator. Margaret and Ben are going to be the folks from NASA JPL talking about SWAT. I will hand it over to y'all. Go ahead, Summer.
All right. Thanks, Das. Actually, I do want a compilation of all the times you've said the consortium throughout all of the Virtual Astronomy Lives.
Sometimes I just put it on the screen, so, you know, it's an accessibility thing.
All right. Hi, everybody. Apologies for my dull background and weird lighting. Last minute change of plans because New Mexico internet is not dependable sometimes. So hello and welcome to our discussion about SWAT, which is the Surface, Water, and Ocean Topography mission at NASA, run out of JPL. And our two amazing guests today, we're joined by Margaret Srinivasan, who's the Applied Science Systems Engineering Group at NASA JPL, and she is the SWAT Deputy Program Associate for Applications. And we also have Ben Hamilton, who is a research scientist in the Sea Level and Ice Group at NASA JPL and studies the ocean with a particular focus on sea level variability on interannual to decade timescales. Margaret and Ben, thank you so much for joining us today.
My pleasure.
Thanks for having us.
Can I start out with my normal question, which is just how did you first get interested in science and engineering, and how did you come to work at NASA and on the SWAT mission? Who wants to go first?
I can go first. So I am a scientist now, as you mentioned, but my background's in aerospace engineering, and my early graduate work really started out looking at satellite altimeters and trying to measure the ocean from space. I thought this is really cool. I know it's kind of a weird shift for an engineer to start working on oceanography and some of these ocean topics, but to really be able to understand this really important part of the Earth, the ocean, which is playing such an important role in climate change, it really started to capture my interest. And just over time, I've continued to work on these satellite altimetry missions, studying sea level. Sea level rise is a big problem that we see along the coastlines, and I think having that societal benefit element to the work we're doing is really interesting. But that's evolved over time, so continue to work with the progression of satellite missions up through SWAT, which we're going to talk about today.
Right on. And have you always been at NASA, or did you do some missions elsewhere before, or you just
Yes.
NASA for life?
No, so I came to NASA from Old Dominion University. So I was a professor there in coastal Virginia. So I got firsthand experience with the coastal flooding problem that we're experiencing along some parts of the U.S. coastlines. I mean, that really did inform part of my interest in coming back to NASA to really work on sea level missions. I'm also team lead of the NASA Sea Level Change team, and that's a pretty big science team made up of scientists from NASA, from academia, where we try to come together and use the observations from satellites that we have really to improve our understanding of what's happening along the coastlines and in the ocean.
Very cool. Margaret, how about you?
Well, I grew up in New Mexico, as I mentioned, Las Cruces, New Mexico, and my parents were always very interested in science. In fact, not the first person in my family to work for NASA. My mother worked for NASA when I was little. When I was born, she was working at White Sands Missile Range as a nurse, and she was meeting the Apollo astronauts, and she was just a real Apollo and NASA fan. And so we grew up with the whole NASA, watched all the launches and stuff growing up, and so it was sort of a family culture thing. And also I was interested in science. I just became, through that, and just through my upbringing, I became interested in science, and I got an undergraduate degree in geophysics from the University of Texas, and then a degree in environmental and science and policy from Johns Hopkins. And I started out in energy and environmental fields, and then I came to JPL in about 22 years ago. And I came as an applications person to JPL on the Topex, Poseidon, Jason, the altimeter emissions, the ocean altimeter emissions that Ben mentioned. So, and now it's SWAT's the next mission in the series. And so we're very pleased to be speaking about it today, and very, very excited about the mission. It's just going to be an amazing science and applications resource.
Yeah, I bet. So it just launched last month, and it has since fully unfolded. Is that correct? So the instruments and the solar panels, we have a video of it unfolding, I believe. How large is this satellite roughly, the spacecraft?
Yes, so the main instrument, which you'll see kind of unfolding here, this is the solar panels deploying, but the main instrument, the what we call the Karen radar interferometer, which we'll talk more about in a little bit, is about 10 meters long. So the boom is about 33 feet in length. I think the comparison for the bus, that main part of the satellite, is roughly the size of a car. Is that right, Margaret? Maybe there's a better analogy there, but that gives you a kind of so you can see the antenna there on folding and deploying. So that right there, which you'll see, is about 10 meters in length, about 30 feet in length.
When it gets fully extended.
Right. So these arms right here, the length from one to the other is about, again, about that 30 feet. So that gives you an idea of the scope there, I think, of the main part of the spacecraft too.
And how many different instruments are on it? You mentioned the interferometer, and there's an altimeter. What else is on there?
Yes, so there's I'll maybe take the first one here, Margaret, then I'll kick it over to you. But there's a radiometer that's on there. So when we talk about measuring the height of sea level, you're sending a radar pulse down to space. I mean, down from space to the surface of the ocean, and you're essentially trying to track how long it takes for that pulse to get from the ocean and back. Anything that affects how quickly that pulse can move, that microwave radar pulse can move through the atmosphere, matters to us. So in order to get that really accurate measurement of surface height, of water height here on Earth, we need to have a good understanding of that. One thing that causes a delay is water vapor. So we need an instrument, a radiometer, to really measure the amount of water vapor, and then we can correct. Margaret, do you want to take other instruments that are on there?
Well, yeah, of course, there's the Jason class altimeter, which is the nadir altimeter that Ben mentioned. And then there are three positioning instruments, because you have to know the actual position in space of the spacecraft very accurately in order to get these very high resolution measurements. And so there's something called the Doris antenna, which is a European instrument, which is a ground-based radar beacon. There's a X-band. That's for transmitting the data. There's a laser retroreflector array, and a GPS receiver. And so those are the positioning instruments. And then there are two instruments for the transmitting data about the spacecraft, which is the S-band, and then the actual science data to the ground is X-band.
Doss, are you going to do some of your Madden red marker magic?
See, the problem is that I can't be like, oh yes, well this is the primary antenna that transmits this, and then this is the, and it, like I know Karen is like, their booms have something to do with that, but what should I circle?
So the first thing you circled is the radiometer, that one that's kind of coming off the side.
Yeah.
That whole bottom, yeah. So that whole bottom area, that really makes up what Margaret and I were just talking about, kind of that orbit determination package, knowing exactly where the satellite is at any given time. And then the nadir altimeter is there as well. But that's where a lot of that. I mean, we already. I'm touching this briefly. It's really important we know exactly where that satellite is and exactly what happens to that radar pulse when it's traveling. So there's all these other instruments, not just the core science payload, that are really critical.